The universe is 93 billion light years wide, but it's only 13.8 billion years old. Do the math. Something is broken. If nothing, not a rocket, not a radio signal, not even light can travel faster than 300,000 kilometers per second, then in 13.8 billion years, light could only have crossed 13.8 billion light years. That's it. That's the ceiling. So how is the observable universe 93 billion light years across? Either Einstein was wrong, or something far stranger is happening. Einstein wasn't wrong, and what's actually happening will make you question everything you thought you knew about space, distance, and reality itself. First, understand the scale you're standing in before we break the math. You need to feel just how enormous this problem is. And to do that, we have to start right where you're sitting. You are roughly 1.7 meters tall. Your house fits around you. Your city stretches a few dozen kilometers. Earth, the whole planet, is about 13,000 kilometers in diameter. If you drove non-stop around the equator at 100 kilometers per hour, it would take you over 16 days just to get back where you started. That feels big. It isn't. The moon sits about 384,000 kilometers away. 30 Earths lined up side by side would barely bridge that gap. Apollo astronauts needed 3 days to reach it. A car at highway speed? 5 months. And the moon is essentially our cosmic backyard. Light crosses that distance in just over 1 second. Now scale up. The sun is 150 million kilometers from Earth. Its light takes 8 minutes and 20 seconds to arrive. If the sun vanished right now, you wouldn't know for more than 8 minutes. You'd be sitting in sunlight that no longer existed. Neptune, the farthest major planet, orbits at 4.5 billion kilometers out. Sunlight takes over 4 hours to reach it. But even Neptune is not the edge of our solar system. Beyond it lies the Kuiper Belt, and far beyond that, there may be an enormous shell of icy debris called the Oort cloud, so vast that light could take between 1 and 2 years just to cross it. 1 light year is nearly 9.5 trillion kilometers. Our own solar system may be 2 light years across. That is not a typo. Stepping into true darkness now, leave the solar system. The nearest star system, Proxima Centauri, sits 4.25 light years away. The fastest spacecraft humanity has ever built, NASA's Parker Solar Probe, travels at around 690,000 kilometers per hour. At that speed, reaching Proxima Centauri would take roughly 6,700 years. Entire civilizations would rise, collapse, and be forgotten before the probe arrived. And that is our nearest neighbor. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Its disk stretches about 100,000 light years across. If you shrank our entire solar system down to the size of a coin, the Milky Way would be the size of North America. Our sun sits out in one of the spiral arms, about 27,000 light years from the galactic center, and it takes roughly 250 million years to complete a single orbit around the galaxy. The last time the sun was in roughly this position, the first dinosaurs were just beginning to walk the Earth. Every single star you've ever seen with the naked eye belongs to this galaxy. The faint smear of light stretching across a dark sky on a clear night? That's the combined glow of billions of stars crowded toward the galactic core, so distant that their individual light blurs into a single pale river. And the Milky Way is not alone. If this is already bending your mind, stay with it, because we haven't even gotten to the part that breaks the math yet. Keep watching, because the answer is one of the most beautiful and strange ideas in all of science. The scale beyond our galaxy, the Milky Way, is part of a small cluster of galaxies called the Local Group. Our nearest large galactic neighbor, Andromeda, is about 2.5 million light years away, and it's moving toward us. In roughly 5 billion years, the two galaxies will collide and eventually merge into one enormous structure. But zoom out further, and the local group is just a neighborhood in something far larger, the Virgo supercluster, containing over 100 galaxy groups and spanning about 110 million light years. Zoom out further still, and even that disappears into something called the Laniakea supercluster, a name drawn from Hawaiian meaning immense heaven. Laniakea stretches about 520 million light years across and contains roughly 100,000 galaxies. The combined mass of everything inside it is approximately 100 quadrillion times the mass of our Sun. All of those galaxies, including ours, are drifting toward a gravitational focal point astronomers call the Great Attractor. At the largest scales, galaxies aren't scattered randomly. They organize themselves into something called the cosmic web, vast filaments of galaxy clusters connected like threads, surrounding enormous empty regions called cosmic voids. Seen from far enough away, the entire structure resembles a neural network, glowing strands of matter surrounding deep, dark hollows of almost nothing. The observable universe, this entire web, stretches 93 billion light years from one side to the other. And now, you're ready for the answer. Why the math seems broken, and why it isn't. Here is the key insight that most people never learn. Galaxies aren't simply flying outward through space like debris from an explosion. What's actually expanding is space itself. Imagine drawing two dots on a rubber band. Now stretch the rubber band. The dots aren't moving along the rubber band, but the distance between them grows anyway. That's what's happening across the universe. Space itself is stretching. Galaxies are being carried apart not because they're speeding through space, but because the space between them is physically getting larger. Now imagine an ant walking from one dot toward the other at a constant speed. The ant keeps moving forward, but the rubber band is stretching underneath it. The distance the ant has to cross keeps growing while it's still crossing it. That's a photon of light. When a galaxy 46.5 billion light years away sent out light billions of years ago, that light was not 46.5 billion light years away. It was much closer. But as the photon traveled toward us for 13.8 billion years, the universe expanded around it. The galaxy it came from was carried further and further away. By the time that ancient light finally reaches your eye, the galaxy that emitted it is now 46.5 billion light years distant. Nothing broke Einstein's rule. Nothing moved through space faster than light. Space itself expanded, and there is no speed limit on the expansion of space. The cosmos isn't bound by the same laws as the objects inside it. This is why the universe can be 93 billion light years wide, while being only 13.8 billion years old. The size is not a contradiction. It's a consequence of the fabric of reality stretching in all directions, continuously, since the very beginning. What lies beyond the edge here is the final twist. The observable universe is not the full universe. It's only the part from which light has had enough time to reach us. Beyond that boundary, the cosmic horizon space almost certainly continues. The total universe may be unimaginably larger than what we can observe. It may, in fact, be infinite. We cannot see it. We cannot measure it. We can only infer it. In the first fraction of a second after the Big Bang, according to a theory called cosmic inflation, space expanded at an exponential rate so extreme that a region smaller than a single atom may have stretched larger than an entire galaxy almost instantly. That early burst of expansion planted the seeds for everything we see today, every star, every filament, every void in the cosmic web, and it may have expanded space far beyond any horizon light could ever bridge. The edge of the observable universe is not a wall. It's a horizon in time, a boundary set not by space running out, but by the age of the universe itself. The most astonishing part here is what should truly stop you. You are one person on a small planet orbiting an ordinary star in a quiet corner of a spiral arm, inside one galaxy out of 2 trillion, embedded in a cosmic web stretching 93 billion light years across an observable universe that may be only a fraction of what actually exists. And yet, you understand this. The atoms in your body were forged inside stars that died billions of years ago. You are a brief arrangement of ancient stardust that somehow became aware of the universe it came from. And through mathematics, physics, and centuries of patient observation, we have measured the moon, mapped the sun, charted superclusters, traced the cosmic web, and solved the very paradox we started with. The universe's size doesn't add up until you realize that space itself is alive, stretching, expanding, carrying galaxies apart while ancient light crosses the growing distance to reach your eyes. In a universe almost beyond imagination, the most remarkable thing isn't the scale, it's that something inside that scale looked up, asked why, and figured it out. If this made you see the universe differently, share it with someone who needs their mind blown today. And if you want to go even deeper, the expansion of the universe isn't slowing down. It's accelerating. That's a whole nother story.